Hello. Thanks for joining another one of our interesting podcasts. My name is Mondo Mikhail. I'm the Systems and Solutions Architect with ADLINK Technologies. Today, I'm very grateful again to have Joe Speed. He is the head of Edge at Ampere Computing. This is our second podcast together. The first one we discussed hyperconvergence. Our interesting discussion today is going to be the convergence of OT with IT, OT and IT together. So I'm really eager to get this started. A brief bit about Joe. Joe Speed is the head of Edge at Ampere Computing. He's done some really interesting things. Joe and I worked together in the past at ADLINK Technology. He was our field CTO there. He's with Ampere Computing. He has been part of the Open Robotics, the ROS2 operating system, getting that to open source on the technical steering committee, also the AutoWare Foundation. He has been ADLINK Field CTO. Joe's a technical advisor to the Indy Autonomous Challenge. We worked on that together. That was really fascinating. We actually worked on getting completely autonomous F1 cars, Formula One cars in the Indianapolis racetrack at track speed. That was a really cool thing to do. Joe, it's very nice to speak with you again. How are you doing?
I'm excellent, Mondo. It's always a pleasure.
Today's topic, is very interesting to me. It's the convergence of IT and OT. These are very kind of cool topics. A lot of people know what they are by hearing them, but I don't think they know exactly what each of them are, how they differ, and what it means when you bring these two technologies together. So let's begin. Can you help us understand what each IT and OT really are?
Yeah, so with IT, information technology, that originated with mainframes, servers. So think about back office. You're dealing with data and business operations, analytics, these kinds of things. The OT, operational technology, that's all about the operation of your physical plant, right? So direct digital control of machines and other equipment. So in the factory, in the warehouse, in the field. And these were historically separate because they have these very different origins.
Interesting. I know in the past, in a previous life, I was at a company where we did a lot of SCADA systems and PLCs. There was some very kind of crude software that went along with it that captured data. It gave you some really crude analysis of it. You can catalog it and so forth. So when we talk about IT and OT convergence, when these two technologies actually convert together, I know the IT or the information technology group tended to be its own kind of fiefdom, and then you had on the operations side all these devices, sensors out there gathering data, doing their thing. With technology evolving and the use of AI and so forth, what does it mean when these two converge now, and where does that convergence actually happen?
Yeah, so you and I, we've got a lot of shared experience that colors our perception of this. So looking at this IT-OT convergence from an edge compute, industrial IoT lens, I'll paraphrase and really oversimplify to say that IT deals with the data, the lakes, and the streams, while OT deals with the events, the here and now. Some people are really passionate about data lakes, but I'm not one of them. Once the data's landed, it's dead to me and ceases to be interesting. I'm all about the events that occur in the real, how they're observed and acted on in the here and now.
Interesting. I agree with you from a data sense. I mean, it's real time. It's very fluid. It's very dynamic, and I agree that once it's kind of hit a storage device or is ingested for the first time, it is stale because it may be different a millisecond later, and that data difference could mean a huge impact on the network or on the devices it's monitoring. So why is this important? Why should we care about this? And what are the drivers for this? I know there's some great technology that's been implemented. Also, the whole field of digital transformation, this has been going on maybe in the past 7-10 years or so, that the data that's represented digitally used to be just stored. Once it's captured, something's acted on it, like you said, at the OT level or the IT level, it's stored. So why do we care about this now?
Why you care, if you're looking from a business perspective, it's how do you get a view of your entire business and run your entire business, including how things are made, how they're serviced, how they're supported, how you're running your plant, how you're running all your physical assets, all of these things, that is part of your business. And, you can draw an analogy there that, for example, in retail, you've got, and this is not really so much OT, but, the stores, they may be satellites, but they are core to how your business gets run. So in terms of some of the things that bring us together, so connectivity, right? So think about clusters of computers, right, in the back office and the data centers. Well, that's in a lot of ways analogous to what you have out in the field, which is fleets of devices. And so, and then the connectivity, the commonality, bringing the best practices, the best technologies together. I'd say cloud and IoT are really two forcing functions here. So with cloud, you're talking about how do you deploy and manage things at scale, which also has quite a bit of applicability to what's happening on the device side, right, with fleets. So with that scaling, how do you get the efficiency, the operational efficiency, the manageability? How do you get consistency? How do you get security and being able to apply that consistent? And I think these are some of the things that enable us to start to bring these OT and IT worlds together so that they can be acted on together, treated as one thing.
That's pretty cool. I know connectivity now is ubiquitous. Everything has connectivity. I mean, the obvious is our cell phones and home computers and so forth. But a lot of people could take it for granted that as devices got smaller and smaller, and Wi-Fi devices or RF communication devices got smaller and much less expensive, almost anything is connected now, from the smallest sensors out in the field, our televisions, our refrigerators, even I saw a device that had a connected toaster, if you'll believe that. But what's really cool about the applications, I think, that drive these functions is their portability. They can now be located anywhere. I know in the past, in my previous life, the OT applications, the SCADA applications, were resident on the PLC or device right next to it. You have to go plug something in to get it off and then munch it and machinate it. Now this data is portable. It can literally live anywhere. And that's kind of to me, a very interesting concept, that data portability. So it makes it available to computers, whether they're in the IT section or actually in the cloud infrastructure. And I think that's where Ampere really lies.
Yeah, and this whole portability, the virtualization. So what's happening is you've got all these technologies endemic to the cloud, right? The virtualization, hypervisors, containers, all the Docker, Kubernetes, all these things. And, I think you can pick apart like software-defined vehicle, what's happening in a vehicle, as a like representation in miniature of what's now happening in the factories. So in a car, historically, you had like 100 to 200 microcontrollers, microprocessors, so MCUs, ECUs, and each of them was a dedicated function, okay? So it was like a little bit of software married with a little bit of hardware, and that did one specific thing, like your windshield wipers. And what's happening now is the architecture is collapsing to have a small number of more powerful things, and everything's virtualized, containerized. And so you get a lot of flexibility of function. And actually, not all the function even has to be in the car. So you can develop in the cloud, deploy in the car, run in vehicle, near edge. And we're not talking about cars today, but it's interesting because there's a lot of analogs between that and what is happening and will be happening in the factories and warehouses and other kinds of OT environments.
That's awesome. I also think about drones as well. All these vehicles to everything, whether they're cars or drones, they're gathering tremendous amounts of sensor data, and the connectivity, a lot of them are being driven by 5G, which gave us huge leaps of bandwidth and connectivity boosts. You can gather this data, and as you said, you can have your IT infrastructure sitting in the cloud, and all these different applications run on containers and so forth are completely portable. So when you're doing real-time navigation, you're doing real-time drone control and so forth, it really makes it critical that these sensors or the operational side of it that control functions, whether they're drivetrains, whether they're, data gathering, LiDAR sensors to help navigate a vehicle, has tight connectivity with the cloud or the IT infrastructure so these applications can stay running.
Exactly.
Wow.
So think about, from the cloud and the enterprise side, you want to manage it and have the insight, but you have to have local data collection and decisioning and control. Because, if you take it to the cloud for a decision and then back, it's too late, too slow. The product's been damaged, the machinery's broken, the building's burned down.
Right. And with something as, we like I said, automated vehicles, autonomous vehicles, was something that critical where someone's life is in danger. And there's also other kinds of processes, whether in hospitals, whether they're in utilities and so forth. These things have to be real time. They have to be processed correctly, the connectivity between the data and the actual intelligent devices, with machine learning or AI that actually crunches these devices and actually makes decisions based on that, and then goes back and communicates with the OT sensors and so forth. It's just really changing the landscape. So let me ask you this: well, what's this got to do with Ampere computing and ADLINK? What's the position of Ampere computing in this space, and what's the advantage? I know there's many, but help our listeners understand that.
Yeah. For the IT/OT convergence, you've got a lot of innovation that's flowed. The obvious thing is people think about, I take my IT and I just propagate that technology and best practice to the edge. But there's also some flow the other way, right? So from the edge to the data center. So you think about like ARM architecture, right? That was already proven and widely deployed, widely used in OT for a small footprint, energy efficient, very reliable compute there for your operational technology. And very energy efficient, very green operation. So our innovation was to take that, scale it up and out, and make it successful in the data center. And it wouldn't be an exaggeration to say that Ampere Ultra ARM processors are in all the big clouds but AWS, who developed their own very similar processor. And now what ADLINK has done is you've taken that from the data center right back to the edge, back to its roots. So using Ampere's cloud native processor for small footprint, energy efficient OT that scales up, right, higher performance cores, and scales out, so up to 128 cores per module, right, for the ADLINK compute modules, and you can have many modules. So it scales up and out like nothing that has existed before there in the OT environment. So like with the single ADLINK compute module, that performs like 100 Raspberry Pi 4s, but is even more energy efficient.
Right. I know what we love. We designing with Ampere computing CPUs. What we really like is the power profile. I mean, you can have up to 64 cores and less than 70 watts, and that's very unique. There's no other CPU architecture that matches that. What's especially cool, and I think you turned me on to this, the CPUs that aren't running or aren't being utilized are virtually taking zero power. And that's really tremendous when it comes to power, cooling, and space as well. So when you're trying to scale up and scale out, you can use a CPU that has 64, 128, or even 192 cores and really be power efficient and only use those cores when you absolutely need them. So you can dedicate applications, whether they're containerized and so forth, on an individual core basis and really control your power profile and your rollout. That's really quite unique. And we've enjoyed those capabilities when we design with your chips.
Yeah, where I think this is all headed is you start to think about your OT environment being in the vehicles. Again, another analogy, right? They're moving to think about software-defined hardware, software-defined vehicle. In your OT environment, you can have the compute be practically like a software-defined hardware. So an idle core uses almost nothing. It's 62.5 milliwatts, right? So, for example, if you think your workload needs 32 core, for a few dollars more, just do a 64 core and you can manage, like with Kubernetes, you take your workloads, pin them to cores. Idle cores use almost no power. So now you've got this small footprint, small power, very energy efficient, but you also have this flexibility to grow it, right? You can just turn on additional, you can go ahead and start pinning more workloads to more cores and scale it as needed, like all within that same footprint.
That's cool. Hey, do you have a couple of cool examples for us quickly?
Sure. So, one of the ones that I guess for you and I, we think of this is the classic example, right? So, edge AI, right? Computer vision. There's a lot of things you use AI for at the edge, but the one most people talk about is computer vision, because those are particularly high bandwidth sensors, right? It's a computationally expensive operation. So for those, think about you collect data at the edge, you train in the cloud, you do your inference at the edge, because that's where the events happen, and that way you can get the low latency inference, your real-time controls, all of these kinds of things. So, that's a really good example, because there you're pulling together kind of your IT, your data centers and corporate clouds, doing this training, inference at the edge, and then all those inference results, taking action on them locally, but also rolling up all of those inferences so that you can have a macro fleet view of, what's the health of all my machines, right? What's the quality of the products being produced on all the lines, not just this one line.
That's really cool. Joe, I want to thank you so much for joining us today. It's always such a great pleasure talking with you. Your passion and your exuberance always comes through, and I always found that such a blast to work with. So thank you.
Always a pleasure, Mondo. Talk to you soon.
Thank you for joining us today on another very interesting podcast. We hope you learned a lot. I know I did. So we appreciate your time, and we look forward to you on our next podcast. Thanks again to my special guest, Joe Speed, and we'll see you next time.